In today's Daily Dose of Math, we are looking at our bicycle taxi example. It's up here. We're being asked to graph both of these situations, find equations for both, and then use the equations to answer a question for each. Let's start with the first one. We have to define our variables. X is equal to the number of kilometers. Y is equal to the cost of the taxi ride. The initial value of $10 that everyone has to pay is our b, our y-intercept. We're using the form y equals ax plus b. So we have plus 10. And then the $2 per kilometer is the slope. So we have y equals 2x plus 10. How do we know this is linear? Well, the fact that we have a unit of dollars per kilometer is a bit of a clue that it might be a linear, because slopes, units of measure, have a tendency to be unit slash other unit. So dollar slash kilometer makes me think of a slope. Then we make our graph. I'm making it nice and small. We know that when you get into the bicycle taxi, it costs $10. So we need $10 to show on our y-axis. And we have a point here. This is our initial value. It's our y-intercept. It's our b. The fact that we have an intercept, that's something that doesn't happen with the inverse function. So that's another thing that's telling me this is linear. Then I need to find another point, so I draw my line in the right place. So I'm going to try plugging a value into my equation. Let's say the number of kilometers is 5. We have y equals 2 times 5 plus 10, which is 10 plus 10, which is $20. And that gives me a second point. If x is 5, y is going to be 20. And we have a point here. We're able to draw a line through the points. We have our graphed linear function. I need to label my axes, so I'm going to put dollars on the y-axis and kilometers on the x. I've done everything with the first of the functions. Let's look at the second one. Here we're talking about people splitting the cost of something, and that is the clue that tells me it looks like an inverse function. I'm going to define my variables. X is the number of people. Y is the cost per person. My form for an inverse function is y equals a over x, and given in the question is the number $30. So we're doing y equals 30 over x. Notice how the information is given a little differently in this function than it is for that one. It's setting us up to use the inverse. Now let's draw a graph. I'll label it right away. X is the number of people. Y is the cost per person. Now we don't have any points given to us to start with. We don't have a point given the way we were here with the initial value, the $10. So we have to use our function and start plugging in some values. Let's say that the number of people is 2. This becomes 30 over 2. It's going to cost $15 each. We can make a point. I'm going to put 30, 20, 10 on my x-axis, and I'm going to do the same thing on the y. 10, 20, 30. Not much room for writing the 20, so I didn't write it. Okay, so 2 people, it costs $15 each. That's going to be about here. 10 people costs $3 each, so that's going to be here. 30 people, it would cost $1 each, so that's going to be way down here. And if we only had one person, it would cost that person $30. So we have a point here. And we're having the curve start to show itself of an inverse where the curve approaches both axes but doesn't want to touch either axis. So now we have our graph. Let's plug in the values that we were asked to plug in. For the first one, we have a 10-kilometer ride, so we have y equals 2 times 10 plus 10, which is 20 plus 10, which is $30. Oh, that's interesting. The $30, that's the answer to the first function's question, is the $30 that gave us the second function. And for the second function, if there are 6 people, y equals 30 divided by 6 equals $5 each. We're able to make a linear function in y equals ax plus b form and make an inverse function in y equals a over x form. We remember to define our x and y in both cases because you get marks for doing that. And defining your x and y clearly makes it easier to make the equation. We're able to graph each of them, remembering to label things. And we're able to plug a value into each function in order to answer a question, remembering to put the unit of measure. We're also able to plug values into functions to give us points that help us draw the graph. And we did that in both cases. That is today's Daily Dose of Math. Please like, subscribe, and share.